This is 5.4, exponential graphs. What we're going to do is we'll give you some equations and have you graph them, give you some graphs, have you come up with the equations. So let's start with this. So we gave you sort of the standard format of an exponential function. F of x equals a times b to the power of x minus h plus k. Each one of these variables, a, b, h, and k, have a graphical meaning. If we elaborate on the base, we talked about last time how if your base was greater than 1, then you have exponential growth. And that graph looks something like this. We also said if b is in between 0 and 1, you have exponential decay. And that graph looks like this in general. The other thing we talked about was this variable a, and we called this the initial value. It also represents the y-intercept, which is 0, comma a. So that was an important point, 0, comma a. There was another point that was just as important, and that was when you plugged in the point 1. So when you plugged in 1, you obtained the point a times b. This point right here would be 0a, and this point here would be 1a times b. Finally, the last two variables are h and k, h coming from the power x minus h, and k coming from a constant that you add at the end of the equation. And these are the same h and k we've been playing with the whole entire time. H is your horizontal shift, and k is the vertical shift. We've identified what a does. A controls your initial value. It is also a player in the 1, comma ab scenario. So you have to be aware of what a is. B controls your base. H and k control your horizontal and vertical shifts. So here we have a function. F of x equals 4 to the power of x plus 5. And what we'd like to do is fit this into the format a times b to the x minus h plus k. So I'd like to know what is a, what is b, what is h, and what is k. We have a, b, h, and k. And what we'd like to do is we're going to take a and b and we're going to graph them. And so we're going to find 0, comma a and 1, comma ab. A is our initial value. It happens to be 1, so we'll plot a point at 1. So 0, 1, this point is 0, 1. And the other point that we're going to plot is 1, comma 4, because 1 times 4 is 4. So 1, comma 4 is this point. So these are our two values, and if we were to sketch this graph, so this is what the graph should look like, not including h and k. Okay? All we're talking about is a and b. So looking at just a and b, we can sketch a graph like this. Now let's employ h and k. So you apply your horizontal and vertical shifts to this baseline graph. So we're going to have a horizontal shift of -5. So we're going to move this entire graph to the left -5 units. So watch this. I'm going to grab this graph, and I'm going to shift it 5 units to the left. 1, 2, 3, 4, 5. I'm not going to shift it up and down because k is equal to 0. So this now changes our points. And what we could do is we just need to subtract 5 from our x coordinates. So instead of 0, 1, this is going to become -5, 1. And instead of 1, 4, this point will become -4, 4. So all we're doing is subtracting 5 from our x coordinates. That's what the horizontal shift does. So our graph has a point at -5, 1. Their graph has a point at -5, 1. Our graph has a point at -4, 4. Their graph has a point at -4, 4. So you take A and you take B and you plot two very important points, 0A and 1AB. That will give you the general shape of the graph. And then you apply a horizontal and vertical shift. So f of x is equal to 1/4 x minus 3. And again, we want to sort of custom fit this to the format a times b to the x minus h plus k. And we'd like to know what is a, what is b, what is h, what is k. A is 1, b, 1/4, and this implies that we have a decay function. H, positive 3, k, 0. Using a and b, we're going to have the points 0, 1, and 1, 1/4. And we got the 1/4 by taking a times b. So we can plot these. 0, 1, right here. 1, 1/4, right here. And that's going to be hard to graph. So in this case, what we'd like to do is take -1 and plug it into the function. You're going to get positive 4. So that's going to be -1, positive 4. So actually we have 3 points. -1, positive 4, 0, 1, and 1, 1/4. So now what we get is a graph that looks something like this. If you have an exponential growth function, that AB is just fine, like in the function that we did before. If you have an exponential decay, instead of graphing positive 1, you may need to graph -1, because that will give you that nice whole number that you're going to be able to plot. All right, so this is the graph if we don't employ H and K, if we only considered A and B. So now let's employ H and K. So H is positive 3, so we're going to take this graph and we're going to shift it to the right 3 units. 1, 2, 3. When you do the shift, you need to add 3 to all of the x coordinates. So instead of a -1, we have a positive 2. Instead of a 0, we have a 3. And instead of a 1, we have a 4. There was something that was mentioned a little bit earlier about an asymptote. Notice that k is actually a horizontal asymptote. At the point y equals 0, you actually have a horizontal asymptote that this graph approaches but never crosses. The function is f of x equals -1/4 x plus 4. All right, so let's take A and B, and let's put them together and see what we can come up with. So the points are going to be 0, -1, and 1, comma, -1/4. So these are the 2 points that we can plot knowing just A and B. So we're going to have a point at 0, -1, which is down here, and at 1, -1/4, which is right there. If you wanted to plot another point, what x coordinate would you pick?
-1, -4.
Yep, -1, -4, which is going to be right here. And so this graph is going to look something like this. Now remember, this is without any H and K shifting. We're only looking at A and B. What do you notice about this graph? Put a negative out in front of the function. What does a negative out in front of the function do? Yeah, it flips it. Look at this one. Positive 1/4. Here's -1/4. It flips it. So a negative out in front flips the graph horizontally. Flips it over a horizontal axis, okay? So we've got A, we've got B, we've got our 2 points. We throw in a third point just for completeness. And now let's apply the HK shift. So how do we shift this one? It looks like we're going to shift it 4 units to the left. So we're going to take these points and we're going to go 1, 2, 3, 4. And that should be our graph. Remember, there's a horizontal asymptote going this way that the graph approaches but does not touch. F of x equals 2 to the power of -x plus 4. What's different about this function? The x is negative. Yeah, we haven't played with one with a -x. This is what we could do. Let's factor out that -1, because I would really like a positive x up there. So I'm going to factor a -1 out of everything. And now this becomes 2 to the -1 to the power of x minus 4. And now 2 to the negative 1 becomes 1/2. So when you have a negative exponent, a negative x up in the exponent, factor out a negative 1. And then using the power rule of exponents, that's what this guy is here, you reallocate that negative 1 to be a power on the 2, and 2 to the negative 1 is 1/2. You reciprocate it. So now we can do A, B, H, K. So let's graph this. Key points are going to be 0, 1, and 1, 1/2. Another key point will be negative 1, 2. So we're going to do 0, 1, 1, 1/2, negative 1, 2. If you wanted to, you could throw in negative 2 and you'd get 4. And so we should get a graph that looks something like this. Now keep in mind, this is without any horizontal or vertical shift. That's the last thing we're going to do. So looking at h equals 4, we're going to take this graph and we're going to shift it 4 units to the right. 1, 2, 3, 4. And that's what our graph should look like. 2 to the negative x plus 4. We have a point at 2, 4, and they have a point at 2, 4. We have a point at 3, 2. They have a point at 3, 2. I think we graphed it correctly. What we've done so far is we've given you equations and asked you to create a graph. So guess what's next? We're going to give you the graph, and you're going to come up with the equation. So here's the graph. A times b to the x minus h plus k. What are some things that you can conclude just by looking at the graph? So y-intercept is equal to, I'm going to put 0, negative 4. This is a decay function, so you know that your base has got to be between 0 and 1. So it could be 1/2, it could also be 1/3, it could be 1/4. It should be a nice number though. So if I were to wager a bet, I would guess that the base is either 1/2, 1/3, or 1/4. K equals negative 5. How do you know K is negative 5? So you have an asymptote at y equals negative 5, and that relates to K. This distance is 1 from here to here. And if we wanted to, we could start picking some points. This point is negative 1, negative 2. This point here is 0, negative 4. And remember, we talked about A and B, where we had the points were 0, A, and 1, AB. If we take away the shift, this point goes up 5 units. 1, 2, 3, 4, 5. And this point goes up 5 units. 1, 2, 3, 4, 5. And we get a graph that maybe looks like this. And this point is negative 1, 3. And this point is 0, 1. So what is A equal to? A is equal to 1. Remember when we built this, we started with A and B, and we graphed something, and then later we added H and K. So what we're doing now is we're reversing this process. We're removing H and K first, and now we're looking at A and B. So when we remove K, or when we undo it, we shift the graph up 5 units. That gives us the green graph with the points 0, 1 and negative 1, 3. Now using these points, we figure out A and B. So if A is 1, 1 times B to the negative 1 power equals 3. B to the negative 1 equals 3. B is equal to 1/3. So now I know A, I know B, I know H, I know K. So to write the equation, I would take those values and I'd plug them back up into this guy, and I think we'll get this. F of x equals 1 times 1/3 to the x power minus 5. That should be the equation of that graph. So there's really 2 components, 2 big ideas going on. First big idea is H and K. You got to know how to shift that H and K up and down, left and right. But you guys should know how to do that because we've been playing around with that since linear equations. The second big idea is the relationship between A and B and the points on the graph.